Hi guys, my name is Neelesh Agarwal and today we can discuss the solid principles, a very important design principle in software designing. This video is the first part of a solid principle series and I have five more videos to cover it in details. In this part, I will discuss the basics of solid principle and in the next video, I have a detailed explanation with the practically implemented videos. Let's start the introduction of solid pencil. And in case these concepts are not clear for you and you have any question, please send me. I will like to answer all the questions. Start with the introduction of solid principles. So solid principles are the design principles that help us to solve most of the software design related issues. Solid is an acronym of five principles that are intended to make software design more flexible and maintainable. Solid acronym: S for single responsibility, O for open close, L for Liskov, I for interface segregation, D for dependency inversion principle. Let's go on more in detail on these principles. So single responsibility principle state that a class or a module should only have a one responsibility in the application. As Robert C. Martin mentioned, a class should only have a one reason to change. So if we have a class that have more reason to change, we need to break it in a way so class have only one responsibility in the application. Next principle is open close principle. It states that we must design a class or module in a way that new functionality can be added without changing the existing code. As for Robert C. Martin mentioned, like software entities should be open for extension but closed for modification. Third principle is Liskov substitution principle. It states that the instance of child class must be replaced an instance of the base class without affecting the result of the base class instance. Means where we have a base class object, it should be replaced by the child class object. As Barbara Liskov mentioned, object of a superclass should be replaceable with the object of the subclass without affecting the program. Fourth principle is interface segregation principle. It states that we should break a big interface into smaller and more specific interfaces, and we ensure that implementing classes are only concerned that with the methods they are relevant to them, and we do not force them to implement any method that are not relevant for them. Last principle is the dependency inversion principle. It is said that a high level module and classes should not depend on the lower level module and classes. Both should depend on the abstraction, and abstraction should not depend on the detail. Detail should depend on the abstraction. In case if any of the principle is not clear for you as of now, no need to worry. I will explain you more in detail in the practical session. Uh, the advantage of solid principle. So if we follow the solid principle, we have a many advantages like loosely coupled code can be easily maintainable. It it will have a loosely coupled code that help us in reducing the time to implement new requirement, features, bug fixes. It is easy to test the code, reduce the code duplication, and increase the readability, extensibility, and maintenance. So we have covered the basic of solid principle, and next video I will start with the single responsibility principle practical example. Please like and subscribe my channel. Thank you.